Hello students, welcome to Pythonically. In this video, I will show you how to create a very simple autoencoder for image compression and reconstruction in Keras. Autoencoder is a type of unsupervised deep learning algorithm that is used to basically cluster, group, or identify patterns in the data without the output labels. So in case of unsupervised deep learning algorithms, you do not have the output label. Rather, you just give it unlabeled data and the algorithm actually finds the pattern in the data and clusters the data into groups. So autoencoders is basically used for dimensionality-reduction, for recommendation system, for image compression and reconstruction, for image denoising, and things like that. Here is a very simple example of autoencoder. The inputs and outputs in autoencoder are basically same. So you can see, for instance, consider this is an image with 6 input features, and this is the output image, the same output image with reconstructed output image with the same 6 features. So basically in an autoencoder you have an encoding layer and a decoding layer. The job of the encoder is to encode the input into lower dimensions. So you have 6 dimensions here, there will be an encoder here in this part which will encode these 6 dimensions into 3 dimensions. And then you will have a decoder which basically decompresses the image from 3 dimensions back to 6 dimensions. So you have an encoder which compresses or reduces that dimension of input, and you have a decoder which decompresses or gets the image back to its original dimensions. There are autoencoders with multiple layers, as you can see here. So it has 2 encoding layers and 2 decoding layers. The first encoding layer encodes the inputs into 4 features from 6 to 4 and then 4 to 3, and the decoding layers they decode the input image or decompress the input image back from 3 to 4 dimensions and then back to 6 dimensions. So this is how the autoencoder works. It has same features in the input or the same input and the same output. Now I will explain how to basically create an autoencoder in Keras. It's very simple. We'll be using this Keras blog. So basically what we'll be doing is we'll have an MNIST dataset, which is a dataset of handwritten images. So we will have an input image, we will encode it into lower dimensions using an encoder, and then using a decoder we will decode it back to higher dimensions. Autoencoder is a lossy algorithm because when you encode a huge image into small dimensions, you basically lose some information. So the reconstructed image will not be as good as an input image, but still you can see it's pretty good. It has been able to identify true back to its original 2. So this is the original 2 and this is the predicted 2. You can see that it is a bit blurry, but still you can see that decoder has successfully reconstructed the decompressed image. So let's go back to the code. The MNIST dataset basically comes pre-built with Keras. So all you have to do is simply copy paste this code. So what this code does is you have this function basically loads the MNIST dataset into training images and test images. You can see that we have left the blank space for the labels because we do not need labels in case of encoders. So the shape of our dataset is we have 60,000 records, and each record is a 2-dimensional image of 28 by 28 pixel here, as you can see. So we need to unravel this 28 by 28 2-dimensional image into 1-dimensional vector. So we can do so by multiplying these 28 into 28 784 pixels. Before that, let's first see how one image looks. So you can see this is the code to print one image. The image number 0, or the first image of the test set, you can see the first image is 7 and it is a black and white image. Before we convert it into 1-dimensional vector, we will basically normalize all the images. Since all the images have values between 0 to all the pixel values in the image, because it is a grayscale image, has values between 0 to 255. So we can normalize our image by dividing all the pixel values by 255. So basically this piece of code, it actually normalizes our dataset. Next, you can basically reshape the dataset from 28 by 28 2-dimensional image into 1-dimensional vector of 784 pixels. So you can see, you can simply call the reshape function. The first parameter is the length or the number of records, and the second parameter is the column, the number of columns. So if you pass np.product 1 here, it will basically convert the number of columns to 784. So you can see now our image has been reshaped. We have, in training set we have 60,000 record, each record has 784 dimensions. In the test set we have 10,000 records, and each record has again 784 dimensions. So we are now ready to create our autoencoder. So let's create our autoencoder. Our autoencoder is basically very simple. We will using the input and dense layer and the model. So encoding dimensions are 32, which means that in the input we have 784 dimensions because our input feature will be of 784 dimensions, and from 784 dimensions our encoding layer will encode or reduce the image into 32 dimensions. So encoding dimensions are 32, you can see 32 here. So the input layer will be passed into encoder layer, and encoder will convert the 784 dimensional input vector into 32 dimension. Then we have a decoding layer, and decoding layer will basically convert or decompress the compressed image back to 784 dimensions. So if you print the model summary, you can see that input are 784 dimensional input. Then we have an encoder which basically compresses or reduces the dimensions to 32, and then we have a decoder which basically decodes or decompresses the image back to 784 pixels. Next, we will basically create encoder decoders separately to test the dataset. So you can see this code. So our encoder model will basically, so let's explain first thing. So when you train this algorithm, all these layers will be trained as well, the input layer, the encoder layer, and the decoder layer. So what our encoder does is, encoder basically takes an input image in the form of input layer from here, and it produces the compressed representation of the image. So the encoder will take a 784 dimensional image and will convert it into 32 dimensional image. So the decoder, here we create a decoder. So because the decoder cannot directly use the input layer here, for the decoder we again create an encoded input which will be 32 dimensional. You can see the dimensions here, because the input layer has 784 dimensions, so we cannot directly use it for the decoder, because the decoder accepts the input layer to be of 32 dimensions. So for decoder we can create this encoded input layer. The output of the decoder will be the final layer of the autoencoder. So the final layer of the autoencoder is basically 784 dimensional layer. So basically the decoder model, it accepts the encoded input from here, and then it outputs the 784 dimensional decompressed image. The input to this decompressed image is this, the encoded input. So this is the difference between autoencoder and encoder-decoder model. So autoencoder trains all the algorithm as a whole, input, out, encoder and decoder, and then the encoder and decoder will be used to basically test. The encoder and decoder will be used basically to individually compress the image and then to individually decompress the image. So this is the difference. Next, we need to compile our algorithm or our autoencoder. This function compiles the autoencoder, and finally we can basically train our autoencoder using the fit method. So the number of epochs is 60, or the dataset will be trained for 60 times, and after 256 records, basically the gradient or the weights will be updated, or the algorithm will learn new things. Next, we call the fit method. The input and output are the same training images. The number of epochs, batch size, shuffling is 2, and the validation data is the test images and test set. You can see we are not using the output labels. The input is also training images, the output is also training images. For validation, we are using same test images as input and test images as outputs. So if you press shift and enter here, it will start training our algorithm. You can see the loss is decreasing, and it will basically train for 60 epochs. So after 60 epochs, the loss is around 0.0986. Now we will use our encoders and decoders, the dedicated encoders and the dedicated decoder module that we created in this step here, to basically encode our images and then to decode our images. Remember, when we train the encoder, these layers are automatically trained. So the encoder model will basically take this input 784 dimensional input image and will convert it into 32 dimensional representation. And then decoder has the final layer of the decoder is basically the layer from the autoencoder. So it will use the autoencoder's final layer to basically decompress the input images. So let's first perform the compression. So encoder.predict test images, they are 74 dimensional images, and then after encoding, the shape of the images will be 32 dimensions. So you can press shift and enter here. So you can see we have 10,000 records of 32 dimensional images. Next, we will use the decoder module, which basically decodes the compressed images. The encoded images are sent as input to the decoder, and decoder will create the decompressed representation of the compressed images. So shift and enter here as well. Now we want to basically print the actual images and the decoded images. So I simply copy and paste this code from the Keras library here, and this code will basically generate the first 5. If n is equal to 5, it will basically display the first 5 original images from the test set. You can see test images where n is equal to 5. So the loop starts from 0 to n, and in each iteration it prints the test images, the original test image and the decoded test image. So if you print shift and enter here, you can see the first 5 original images 72104, and at the bottom these are the first 5 predicted or decoded images. So these images at the top, they were basically converted into 32 dimensional form, and then our decoder used that 32 dimensional compressed form as input and predicted these outputs. So you can see that our encoder has quite successfully predicted the images or reconstructed the images from the compressed form. Although you can see there is some loss in the information here, but that's actually encode or compress a large image, you lose some information. But anyways, our autoencoder has successfully constructed the decompressed images, and basically that's how it works. So if you like this video, you can click the like button. If you have any question, you can ask it in the comment section. And finally, I would like that you subscribe to my channel so that I keep making more videos for you. Thank you for watching.